Now let's look at this second problem of homework 14. Determine the moment of inertia and the product of inertia of the area of this problem, the same problem that we just, with respect to the new centroidal axis obtained by rotating the x and y axis through a 30 degrees clockwise. Nice. Moment of inertia and product of inertia. It's the same half a circle and it's 120 millimeter. So let's find the moment of inertia. Again, we will do the same thing. We should find out the x bar, 60 millimeter from the center to the x-axis, that's plus, and this is minus 60. And in this example, of course, the book put A1, A2, the other one put A1, A2. It's the same thing. Whether you put A1 at the top, it should give you the same answer. Let's find out now. Area 1, we know that it's pi r square over 2 because it's half a circle. So it's not pi r square, it's pi r square over 2. So you can find the area 1. Area 1, which is this area. And area 2 is this area. So area 1, area 2. And now x1 is 60 millimeter and x2 is minus 60 millimeter. y1, again, it is, as we know that this is the centroid in the y-axis, 4r over 3 pi. It's a plus because it's going up. That's area 1. Look at area 1. You go from the center of the circle up to find the centroid in the y-axis. That's a plus. So you could find this, and you could find the same thing for that. Now, to find the moment of inertia, area 1 and area 2, about the x-axis is as follows. Moment of inertia for the area 1 is as follows. Ix and Iy, they're equal. It is 1 over 8 by r to the 4. This is the way we do it for moment of inertia of area 1 as follows. So, by r to the 4 over 8. So what is the radius? This is Ix and Iy. Okay? And you could, radius is 120. So this is the moment of inertia of area 1 and area 2 around the x-axis is 814, 3000 millimeter 4. So now, since we have two circles, so we have to sum them up. I mean, two half circles. We have this half circle and this half circle. So we have double. So we have double. So Ix is equal, double that, and that's what gives you the moment of inertia about the x-axis is equal to that. Now, let's determine the moment of inertia of area 1 and area 2 about the y-axis is as follows too. Now, about the x-axis, we just did it without doing the area, because if you look at this, about the x-axis, we did not do the area because there is a match-up between the top and the bottom. About the y-axis, we have to put the area included. So the area here, it's moment of inertia around the y-axis, Iy is pi r to the 4 over 8 plus area times x square. Okay, x is the bar square, so this is x bar square. So this is the radius 120, and the area, of course, this is for area 1, and because they both has the same area, 22619.46. Okay, and 60 is x bar. 60 is x bar. 60 is x bar for the area 1. And of course, the same thing for the other one. So we'll do it. And whether you have 60 and minus 60, it's square, so it will go up and get out. So this is the moment of inertia. You add up because we have two half circles. So this is moment of inertia about the x-axis. This is about the y-axis. The x-axis, we just did it here. Okay? Now, the y-axis, you have to add the area and you have to multiply it by x bar. Now, since we find out the moment of inertia around the y-axis and around the x-axis for both, now let's look at the product of inertia for area 1. Well, here the product of inertia has a different equation. Ixy, now product of inertia means xy. The other one is ix and iy, moment of inertia for the x-axis, or both x-axis. I bar xy, x1 bar, y1 bar times the area. This is, we shall substitute it because there's a symmetry. So this is the I bar, xy is 0. x1 bar is 60, y1 bar is 50.92, you just do it from the table. Area 1 is whatever is given, 22619. Okay, 60 and 50.92. We finish from this. We have that area, y bar, x bar, and you will end up with what? Ixy 691.06974.2 millimeters to the 4. Next, we have to calculate the product of inertia for area 2 as follows. Now, we did that for area 1. Now, we did this for area 2. Ixy 2, Ixy bar, that's going to be 0 because there is symmetry. X2, Y2. So X2 was minus 60, Y2 is minus 50.92. Area, which is the same as the other area, but a minus times a minus is going to be plus, so it's going to give you the same total of the same product of inertia. And then since you have 2, you're going to sum them up, which is the same thing. You will get the product of inertia as equal to this number, 1382.13948.2 millimeter to the power 4. And then, since he need to do it with respect to an angle, you need to calculate the moment of inertia about the x-axis of the new centroidal area at theta is equal to 30. Well, there's an equation. We know Ix, moment of inertia around the x, Iy over 2. Well, Ix, we know it. Iy, we know it. So Ix plus Iy over 2 plus Ix minus Iy over 2 plus cosine 2 theta. Theta is, he just needed for 30 degrees, minus Ixy sine 2 theta. So we know Ix, we know Iy, and we know just now Ixy. So we plug in the number, you'll get this number. Ix, this is dash equal to this number. So this is the moment of inertia about the x-axis at theta is equal to 30. That's it. Now let's find the moment of the inertia about the y-axis of the new centroidal at theta is equal to 30. Now we have another equation. Ix plus Iy over 2 plus minus Ix minus Iy over 2 cosine 2 theta. Look at the difference. Here is cosine 2 theta minus Ixy sine 2 theta. Here, plus Ixy sine 2 theta. These are the two differences. We know Ix, we know Iy, we know Ixy. So you plug it in with the theta 30, you will get Iy dash is that number. This is the moment of inertia around the y-axis at theta is equal to 30, 4.047 10 to the 8 millimeters to the 4. Now the last one is to find out the product of inertia, which is as follows. Ix minus Iy, this is the Ix dash y dash over 2 sine 2 theta plus Ixy cosine 2 theta. We know Ix, we know Iy from the previous one, Ixy. Plug in the number with theta is 30, you will get minus 1.414 10 to the 8 millimeter 4, and that is the product of inertia. Thank you very much.